Let's look at another example of a function, and let's see if we can find its inverse and graph it, as well as the domain and range. Now, if you'll notice this function right here, this is a rational function. It's a fraction, okay? They've already given us the picture over here, but let's talk about a couple of key pieces there. One is the vertical asymptotes. Remember, vertical asymptotes occur when the denominator equals 0. So there's going to be a vertical asymptote at x equals -1, because if we put -1 for x, this denominator would be 0. So sure enough, if I went over here to -1, there's a little vertical asymptote right there. The graph is zooming up to that line on one side and down on the other. Okay. There's also a horizontal asymptote. Remember, that's where we used our Bobo, Botten, Coco rules. So we look at our exponents. Exponent on the top is 1, on the bottom is 1. So they're the same exponents, so it's going to be the ratio of the lead coefficients. So 3 over 1, which is just 3. Okay. Sure enough, if we go to y equals 3, there is a horizontal asymptote. On the left side, it's approaching that horizontal asymptote from the top. On the right side, it's approaching that horizontal asymptote from the bottom. Okay. Now, what I like about this is, let's go ahead and do our domain and range. So our domain is every single x number except for -1, everywhere except for the vertical asymptote. So I'm going to say -infinity to -1 union -1 to infinity. That's our domain. Well, the range, started from the bottom, now we're here, work bottom to top. It exists, it exists, it exists. All of a sudden, when we get to y equals 3, it doesn't. And then on the other side of y equals 3, it resumes. So our range is -infinity up to 3 union 3 to infinity. Now, the reason that matters is once we get our inverse, we don't even have that equation yet, but once we have the inverse, we already know the domain and the range that we're going to get for that inverse. So remember, the domain of the original will become the range of the inverse. So the range of the inverse is going to be -infinity to -1 union -1 to infinity. Because remember, inverses, we trade all the x's and y's. Okay. The range of the original will become the domain of the inverse. So -infinity to 3 union 3 to infinity. Okay. I already know what those are going to look like. Okay. Now, let's find the actual equation. And I'm going to change colors here just because I think it will make it a little easier to see when we graph it. We can see the original function is graphed in blue. Okay. All right. So remember our 4-step process for finding inverses. We put in y instead of f of x. Then we trade the x's and y's. So I'm going to put an x right there and a y in these other places. And then we need to get y by itself. Now, what makes this one a little different is we've got y in a couple of locations. I think it would be a lot better if the fraction wasn't here. So let's multiply both sides by y plus 1. And that will get y out of the denominator, and all the y's will be up on the main line. So I think that will help. So I multiplied the right side by y plus 1. That leaves just 3y. On the left side, when I multiply y plus 1, I'll have xy plus x. That x got distributed. Okay. All right. Well, now at least we don't have fractions. That's good. It would be better if all the y's were on the same side. So what I'm going to do is I'm going to minus xy. Okay. And that's going to get all the y's on one side. We'll have 3y minus xy on the right. And then the next trick I'm going to use here is I'm going to factor out the y. Okay. In other words, I'm going to say, hey, there's a GCF of y. Let's factor that out. Well, y times 3 will make 3y. And then minus x, y times -x makes -xy. And you're going, well, why'd you do that? Well, now, instead of having y in 2 locations, I just have a single y. So I will be able to isolate this y. I can divide both sides by 3 minus x. And that will get y alone. So our new equation here, y equals x over 3 minus x. Okay, now our y is in one location. I could graph it a little bit easier. I could type it into y equals and I could graph it. And then our last step is always, instead of y, use the inverse notation. So f inverse equals x over 3 minus x. Okay, so that's our inverse function right there. If I graph this right over here, it should have the domain and range that we predicted. Okay, well, this is another rational function. So it has vertical asymptotes wherever the denominator equals 0. This denominator will equal 0 at 3. So I know that if I go over here to 3, I can sketch a little dotted line, and that should be my vertical asymptote. It will have a horizontal asymptote. Look at the exponents. It's a 1 on top, 1 on the bottom. So the ratio of the lead coefficients, 1 over -1, -1. So if I go to -1, that should be where my horizontal asymptote is. Now this is a really mess to look at, but let me give you a little trick up here also. Remember how we said domain and range were just reversed when we find the inverse? Yeah, because when we do inverses, x's and y's reverse. So if x equals -1 in the original for our vertical asymptote, then it should be y equals -1 in our inverse, and instead of a vertical asymptote, it's a horizontal. In our original, we had a horizontal asymptote at y equals 3, so in the inverse, it's a change to x equals 3, and it won't be a horizontal, it'll be a vertical. So it's kind of cool how all that works out, okay? If we were to graph just this part, and again, over my little dotted black lines are the vertical and horizontal asymptote, okay? If I were to graph that, you can see there's my horizontal asymptote. It's curving this way, and then it zooms up right next to it here. And then it's in the bottom right section right here. Now, remember on the previous video, we said that it should be a mirror image over the line y equals x. If I graph the line y equals x right here, it's kind of hard to tell, but I think these are mirror images of each other. See how this part and the blue one, the original, went above, and its mirror image is below. This part in the top left corner has its mirror image in the bottom right. So it's kind of hard to tell, but I think they are mirror images of each other on the line y equals x. Okay? All right. Another example here. Part C, our function f of x. They've even given it to us as the graph over here. Notice it's got an x squared, so this is a parabola. And we know that quadratics, if you have an x squared, the plus 3 will shift it up 3. So it's the parabola that, vertex would be at 0, 0, got shifted up to 0, 3. Now notice it's missing the left-hand side. They only drew the right-hand side of the parabola. And the reason they did that was they told us to restrict the domain. They're telling us, hey, graph y equals x squared plus 3, but only for x is greater than or equal to 0. Only the right side of the parabola when x is greater than or equal to 0. Okay? They restricted the domain in the original. Okay, we call that a restriction, only graph part of it. Okay, so when we find our inverse, we're going to have to take this restriction into consideration when we find that equation. Okay, notice our original function, the domain, starts at 0 and goes to infinity, so bracket 0 to infinity. The range starts at the bottom, goes up, so 3 to infinity. Okay. We already know what to predict for our domain and range of the inverse, even before we find their equations. We know that the range of the original will become the domain of the inverse, so 3 to infinity. And we know the domain of the original will become the range of the inverse, so 0 to infinity. We already know that without even seeing the equation, okay? All right, let's take our function here. The original, f of x equals x squared plus 3. First step in finding the inverse is to trade f of x for y. And I'm going to keep for x is greater than or equal to 0. I'm going to keep that domain restriction on there. Step 2, trade the x and y. So we'll have x equals y squared plus 3 for y is greater than or equal to 0. Remember, everything with an x is now a y, everything with a y is now an x. Okay? Here's our equation. This is the inverse right here. We just need to get the y by itself so that we can graph it easier. So we'll subtract 3 on both sides. X minus 3 equals y squared. Still for y greater than or equal to 0. Need to get y by itself, so opposite of squaring is taking the square root. So the square root of x minus 3 equals y for y greater than or equal to 0. And then we probably want to, instead of y, we want to use f inverse symbol. So f inverse of x equals square root of x minus 3 for y greater than or equal to 0. Okay, now one comment I want to make about that. I took a square root. Remember how when we take square roots of things, like if I took the square root of 25, square root of 25 is 5 or negative 5. We usually put a plus minus in front. So when I took this square root of x minus 3, I really should have put a plus minus in front. Okay? The reason I didn't is because I have this restriction right here that says for y greater than or equal to 0. Well, if I didn't have that, yeah, I would need a positive or a negative. But if y has to be greater than or equal to 0, that means y cannot be a negative number. So I don't need the minus. I can never use the minus one, so it's only the positive one. Okay? Another way to think about this, if I graph this over here, well, I know that square root of x starts at 0, 0 and kind of curves up to the right. I know that this minus 3 provides a horizontal transformation. It's going to slide it to the right 3 units. So the point that used to be at 0, 0 is now at 3, 0, and the curve goes kind of up to the right. So if I put in 4, 4 minus 3 is 1, square root of 1 is 1. So if x is 4, y is 1, and so on. And I can draw that curve. Okay? Notice, if I had graphed the full parabola over here, then when I did its mirror image, I would need a full both sides down here on this kind of sideways parabola. But square root function doesn't have the bottom part, and that's why I didn't have the plus minus. Okay? If I had not had this restriction of y greater than or equal to 0, I would have had to put the plus minus, and I would have had to put the bottom part of this parabola, which would have meant I needed the full parabola up here. Okay? But that wouldn't have been a function because then this inverse would have failed the vertical line test because it would have had the points stacked on top of each other. So that's why they restricted the domain here for us. If I graph the line y equals x, 0, 0, 1, 1, 2, 2, 3, 3, and so on, you can see that these two curves are mirror images of each other over the line y equals x. So it works out really nice. Okay? Again, look at our inverse here. The domain of this guy is 3 to infinity. Sure is, starts at 3 and goes right. And the range of this guy starts at 0 and goes up to infinity, and it sure does. And we knew that was going to happen. We knew the domain and range before we found the equation, but it's nice to be able to graph it and verify that that was correct, that it did work. Okay. A reminder, we've mentioned this before. If the point AB is on the graph of f of x, then the point BA will be on f inverse. Remember, we're trading x's and y's. So here's a function, probably some sort of piecewise function. We don't know what the equation was. We could probably figure it out, but we're looking at a graph. They want us to graph the inverse. Okay, well, I don't know what the equation is, so I can't really find the inverse equation and draw a picture from that, but I do know that my original goes through some very specific points, and I could write those points down, and then I know that the inverse will just have the reverse of those points. So let's jot down these points here. And I'm just going to kind of go through in an organized fashion here, kind of a left to right pattern here. So this point right here is at -2, -3. That means its inverse point will be at -3, -2. The next point here is at 0, -2. So its inverse point will be at -2, 0. This point here is at 1, 0. Its inverse point will be at 0, 1. This point at 3, 2 will have its inverse point at 2, 3. So I know the original points, and I know where their inverse points will be located. Let's plot those. So -3, -2 is right here. -2, 0 is right here. 0, 1. And then 2, 3. And if I connect those points in the order that I drew them in, you can kind of tell it's a pretty good reflection over the line y equals x. I drew the line y equals x right through the middle. You can tell that these points up here are mirror images to the original. Okay? So as a reminder, the graph of the inverse is a reflection of the original function over the line y equals x. Remember that line y equals x Whatever x is, y is the same. So if x is 0, y is 0. If x is 2, y is 2. If x is negative 1, y is negative 1. So you notice it's going through those points right here. Okay? And let's look at a word problem and how that would kind of shake out. It's kind of interesting to see how that works. The cost to rent a kayak at a beach resort is a flat fee of $10 plus $10. Flat fee of $10 plus $5 an hour. So if you walk up and you say, hey, I want to rent the kayak for 3 hours, they're going to say, okay, well, it's a flat fee of $10 and then $5 for each hour you want it. You want it 3 hours. 5 times 3 is 15. So it'll be another $15 for your hourly portion. 10 and 15 is 25. They would charge you $25 to rent that kayak for 3 hours. Okay? All right. The cost function, f of x, in dollars, is given by this equation. Okay? And hopefully you agree with that equation. 10 plus 5x. Some people might prefer to put 5x plus 10. So the 10 is the flat fee. The $5 is the hourly cost. Okay? Note that they tell us x is the number of hours that you rent the kayak. So if x is the number of hours, then y, or f of x, is going to be the money you pay. So you walk up and you say, hey, I want it for 3 hours or 5 hours or however long. You tell them what to put in for x, and then what comes out will be how much money you're going to owe to rent the kayak for that long. Okay, so they want us to find the inverse function, and they want us to call it g of x. So instead of f inverse with a little -1 exponent, we're going to just use g of x. Okay. Well, first step, we're going to trade f of x for y. So y equals 10 plus 5x. Then we're going to trade x and y. So we'll have x equals 10 plus 5y. Then we get the y by itself. So to get y by itself, I'm going to subtract 10. X minus 10 equals 5y. And then I'm going to get y by itself. I'm going to divide both sides by 5. So x minus 10 divided by 5 equals y. Okay. Another way to say that, y equals x minus 10 divided by 5. You might prefer the y on the left. And then we need to put in our inverse symbol. Instead of y, we're going to put our inverse symbol. Instead of f inverse, they specifically told us to use g of x. So g of x equals x minus 10 divided by 5. Okay, so here's our original function. It's our cost function. And here's our inverse function, g of x. Okay. Now, notice what's happening here. In the original, x was how many hours we had it, and y was how much money we paid. That's going to reverse in the inverse. In the inverse, y will be the hours, and x will be the money, because remember, x's and y's traded. So now, okay, you're going to walk up to the kayak stand, and instead of saying, oh, I want it for 3 hours, you're going to say, hey, here's $3, or $10, or $25, or however much money you want to say. That's what you're going to tell them, and out will come the hours that you can rent it. Okay? So in other words, instead of saying, oh, I want it for 3 hours, you're going to say, hey, here's $50. How long can I rent it for? Which is not at all how the kayak store is going to do their rental. Okay? They're not going to say, oh, you can have 4 hours and 12 minutes or whatever. They're not going to break it down like that. But that's what this formula is doing. That's what this equation is doing by reversing x and y. Okay? So they wanted an interpretation. So we're going to say, if you pay x dollars, then g of x, or y, because g of x and y would be the same thing, is the number of hours you can rent the kayak. Which doesn't make a lot of sense from a practical standpoint, but that's how we set it up. That's how this equation has been set up. Okay? All right, so hopefully inverses make a little bit of sense for you, trading x and y, and we're going to add on to that a little bit later in the chapter.